YouTubers, this is Roy back again. We're going to take some coral rock, get over here and get some rock. And this rock here, I just drilled a bunch of it and I just put a bunch of powder up from it right there. Let's go ahead. I got the flyback, a little driver, using that capacitor in my last video from the Leedskalnin. And what we're trying to do is look to see if there's any properties in the coral rock that looks like it could be magnetized levitatively or any other way when it's induced by high voltage, fast moving frequencies. Let's go ahead and touch this. And when I touch this, you're gonna see, you can hear the snappy do going. You can hear that sizzling. All right, let's go ahead and decompress the system. Not get blown up over here. All right, and we're gonna move this up just a smidge. Get the distance a little closer. Now, what I want you guys to go ahead and just watch the material. This is coral rock from Coral Castle area, and you can see it move. And let's go ahead and decompress that high tension created. I don't want to get in touch with that. We're going to come up just a little bit more. We're kind of far away. Now, probably it's going to throw it all off because we're about 2.5 inches. All right, you can see it. And that's just, think about this. This is capacitance at its finest. Leedskalnin always said things are stored in obvious places and we don't look at it. You got your separation right here. So you got 12 volts of battery coming out, going into a frequency driver, coming out of a high voltage coil, which these were in your TVs back in the day. That's where the flyback transformer is. And then we're separating that energy and going to 2 plates with a thin film of the plastic as the dielectric for the capacitor. We're gonna come out of that. So here you have 2 plates here, aluminum plates, and they are a large capacitor here as well, which is a variable capacitor here because I can move it. And then you got organic material in the middle. Let's watch the reaction. And let me decompress a little bit. Don't want to get shocked. All right. And we're going to come up just a little bit more, just to give it some excitement. Fire in a hole. And you can see the material is moving. Get a little action going on in there and see if we can. You can see the reaction between the copper in my hand and the aluminum is causing the material. It goes to show you, you have to have, you can see the bouncing up and down. Another great thing is too, is I have this material over here that is some kind of plastic. And it came from a fly stick. There's some crazy ass shit. And we can probably open it. We're gonna pull some of the material out. And this was just known to sort of have a crazy reaction to high voltage. Let's just see what it does. Oh, that's not good. Especially since I don't have my chicken stick, but we'll grab it again. We'll drop it down. All right, you can see there's a lot of explosions going on around it, and it's taking on the material. You can see the material. Look at it levitating up and down. And you can see it's following frequency of the driver. Another thing I want you to notice is, watch when I introduce another element here. This copper coming in the middle. And you can see it bouncing up and down. It's reacting. It'll do a dance. You'll see it dancing? See it dancing? It'll start dancing up and down. It's got a little jolly spot. And you can see the other material. Look at it. How it's moving. Goes to show you, this is just plain old rock, guys, organic. Coral rock from Coral Castle. That's what you have here. You got this material here, which is doing a dance. And let's move this down just a hair. Oh, okay. All right, now we have a dancey thing going. See it? So there's a reaction going on now between the two different plates. And you can see, I'm gonna knock it down just a little bit more. And what you're looking at is just, it's sort of like a on and off switch, because it's charging at one level of a positive and then releasing, making the contact, then releasing, and then it's turning negative, then it's going up and down. So right now it's kind of balances charge out. So the top part of it is the positive, the bottom's the negative, and you can see all the material here is still reactive. You don't have to touch it, it moves. And then you got this guy in the middle. Let's move it down, give him a little bit more space. Oh. All right, we're gonna put him back in place though. I don't want to get near there and touch anything. All right. So it's pretty neat to see a visual of kind of same thing as if you walked up to somebody and you touched them, the higher charge of the person will discharge into the other person and become neutral. And then it'll just continue on and recharge, but you're stuck with that charge that person has left you. This is an example of that. And that's all done by separating powers by that capacitor, which we're working on with the Leedskalnin wheel, which is one of the part of the experiment is taking longitudinal waves and electrostatics and crossing them over within each other and allowing it to transpose on the materials and allow it to vibrate it to its core. And not to the core where it's disintegrating or melting like some people do with metals. They'll go ahead and take the same system I have right here and they'll levitate like a magnet, and then you'll see it turn red and it'll melt and just drop out of its core. And that's just electromagnetic induction at its finest and about the extent of it. No levitation. What you do see is somewhat a reaction of electro induction with high currents, and here you see more of high voltages and less currents. So you won't see the melting of stuff, but you will see like very high. This is high voltage, and this is just 12 volts and a great driver with a high voltage coil. This is nothing more than plastic that's down here, but you can see plastic is a great sort of dielectric, and it just ran up here. It's like hiding from us now. And it's finding its own little path. Well, leave your comments, guys. I'm glad everything is going fine with everybody. I hope you all stay safe. Merry Christmas, Feliz Navidad, Happy Hanukkah, Happy Holidays. And to all of you guys, stay well and stay tuned and leave your comments. Love the comments coming in. Thank you.